Hello and welcome back to another episode of Getting into Good Oxide. Welcome back, Sydney.
Hey, Sebastian.
And a Happy New Year. That's the first
Happy
one.
New Year. A little late, but yeah, still valid.
And a lot has happened in the meantime. We are back with stats, though. It might be the last episodes of stats or one of the last ones, because we'll always regularly return and keep extending it with new things that Git Oxide can do. But the one thing that we didn't really yet explore so much is the access to references. The only ref we've seen is the head, which is kind of exposed as a special thing because it kind of is special, but under the hood, it's really just a ref with special states that it can be in. This is why, these special states, just as a recap, this is why we have an optional result here, which is kind of a bit strange to see, because you would expect the result option, for instance, or something like that, but not here, because that option really just means that there is no commits yet. This is a freshly initialized repository. And that's represented in the type system, and this is why head is a bit special, but that's the only reason. Because if we remember, entirely unprepared here, but if you remember, this is really just a ref, and it's a symbolic one usually. And if it's not symbolic, if there is a hex SHA-1 here, or a hash, then this would mean it's a detached head, which probably many people have already seen. And that's it. That's really all the special thing about the head and how it's represented here. But now I think maybe we can find some stats that tell us about the not so special references, which is, well, what's that? Let's see here. Not so special references, that's the, no, not this one. Let's see. That's the other branches that there are. Right now there's just two, main and index reading. That's branches that the remote knows. There's tags as well. But that's it. I mean, that's tags and references, and tags can have objects. That's also something. And we will see how we can view tags or objects. Tags or references in Git Oxide, and print some useful
that makes sense. So each of these refs is just another entry point, like the head, right? I mean, the head is just the special one, the main one, essentially, but everyone else then works in the same way, that you can look at the commits, you can look at the tree.
Yes.
For special commits, and yeah, it's just the entry.
Because ultimately, what you are interested in is the entry point into the commit graph or into the object graph, more generally speaking, and that's what they all do. And we really have to also say that they can point to any object. It doesn't have to be a commit. It just typically is. But yeah, let's explore that. Let's explore. So let's see. Yeah, what are you interested in? You tell me.
Let's look for branches, for example, if I want to check out what branches exist.
Okay. Let me have the handle here. Let's say num branches. For a beginning, this would mean we kind of iterate branches. What are branches? Yeah, you wouldn't find branches here because it's kind of a, it's not actually, is it Git speak? It kind of is, right? There's a Git branch. But it's not really, I guess, the slightly lower level speak that we have here, but I probably am rationalizing the fact that maybe there should be a branches, right? Because that's how people that's how people think, and for good reason. Let's see if that actually is. All right. Let's see if that actually is a thing. Git 2. If you have branches here. Okay, Git2 has it. Good. So good. Feels always like being a copycat. They have it, so we need it too. Okay, but that's fair. And there's different branch types as well, which means local and remote. Okay, so how does that map to what we have here? So local branches are these that are in heads, that have the heads prefix or the heads path in them. And remote branches are the ones that are in the remotes subdirectory. And that's it, right? So it's more like a filtering on top of normal references, because ultimately it's just refs here. And they're not special at all. But Git makes them special.
I'd be interested to see how you do it now, because I'm guessing that the branches like that doesn't exist yet. It's probably just an abstraction of how we would write it now, right?
I would expect the same, but also let's see what's there. So we have references. Return a platform for iterating references. So platforms, that's a term I try to make a thing. So platform is this intermediate object that gives you more options. Oh, okay, so that can error. Can that error really? Okay, why? That's interesting. Why can that? Because we get the iterator here over references, apparently, and that is set to be able to fail because this currently gets a latest reading on the packed refs, and these packed references, reading that file can potentially fail. This is why getting an iterator can fail. So what this really does is it gets a snapshot on your refs as much as possible. So there are these packed refs, and this one is what you get with this call here. That's this. Give me the packed refs buffer and make sure it's up to date. So this is where it checks if it's in memory buffer of that file is still valid because the file underneath didn't change. And then if something goes wrong there, it can possibly fail. Or it's malformed or something like that. So then that would also fail. Because that's just another way of storing references here. A way that helps the whole system to scale to hundreds of thousands references, whereas the loose files, they usually have trouble to scale to that just because of file system limitations. But overall, I must say, yeah, you would say who needs hundreds of thousands, right? Honestly, but these repositories do exist, and I guess this is the only reason why Git had to do that. That's already pretty neat. I really like this. I do like this repository kind because it scales neatly to quite some size that works probably for most applications out there. And it's reasonably fast and has nice properties when it comes to concurrent writing as well, which actually is a property that isn't met by the successor implementation, which is more limited when it comes to write throughput, I think. So it's interesting trade-offs, but I digress. So this is why this can fail, this call, but then after that we have a platform and we are able to either iterate all references or references by prefix. And this prefix here wants to take a path that looks like this. So it includes the refs prefix. So if you want branches, or refs remotes for remote branches. Yeah, maybe I don't like this here. It must not contain relatives path. Okay. So that's how you specify this. So in order to have the branches, how would our prefix have to be?
Refs head, right? Looking for the local ones. Heads.
This, I agree, looks good. Can result in an error. Can be an error because of this one that can fail? Why can that fail? Because I'll just look for question marks when I see what can fail. And it's the prefix that has to be validated. And if there is one of these forbidden components in there, like dot dot or dot, then this is invalid and then this fails, right?
Is there a reason for making that so free? I mean, are there so many different types of refs, or aren't there always like predefined ones?
This is plumbing, this is low level. So this is kind of the reality of how it's actually implemented, and there's nothing on top that would try to make it nicer. Branches, anybody? So I think this is the reason. What prefix, I mean, you could also ask, why would I not write all and then filter? Because I can, oh, this probably returns something that can error as well. Filter map result, okay, and then I should have the ability to filter once more. And now, what do I have here? What's coming out of there? I think IntelliJ is unable to understand what this is supposed to be, because this should be a ref now, but it's unknown. See, IntelliJ can't follow that, unfortunately. But here you could now also, let's just assume this has a name. And you could, of course, filter here too, right? Yeah, this is pseudocode. This will not work like this, but it's the same principle.
I see. So this is how it internally works. It's really just looking at the path and then just filtering based on that.
And that's the point. No, that's not the case. Because this one is more efficient. This one actually skips over things that don't make sense and limits its search to what actually has the prefix. And this makes a huge difference when going through thousands of refs here, because these are sorted by, you know, it's all binary search, and then you find your starting point and you skip everything that is not matching ever. And then you just go until you are past your prefix. So this is how you actually get to, you know, be very fast when it comes to handling the prefix. And the same happens with the path, with loose references, right? Because then it's kind of like a path, and that's, or a prefix, and that's also implemented correctly here. So refs heads basically just looks in this folder, and the file system takes care of the efficiency there, because it just skips everything outside. But you can also do this. Like this would find main and master and whatever else. Main and master probably is good enough for an example. So this is better than just, oh, now it's a directory. No, it's actually a prefix that works like a prefix, like you would expect. And sure, the same thing can be implemented here, but here you're going through much more data. So that's much slower. And this is why you wouldn't do that. But indeed, branches would be implemented like this. And that's that. And honestly, we could just add this, and then we have something to show for after this episode. Why not? We're 30 minutes in, so maybe I should talk less and do more. So now branches, this should already do something if I count this. And now let's see. Local branches. Here we go with num branches. Oh wait, there's something new on the latest Rust version. Oh.
Wow, I didn't know that.
Yeah. Let's see. So that works. That's pretty nifty. It doesn't support expressions though. So let's see if delegate, if I can actually access fields. I don't think so. Ah, see. So, okay, that's where it stops already. That's too bad. It's more like, it's a bone. It's a bone they throw you. That's a nice bone when it works. Yeah, by the way, there's other syntax. You could use this, num bytes, and here you can have any expressions on the right-hand side. So here this works. but it's kind of more effort, isn't it? Okay. Okay, so we do have 9 local branches. Is that correct? It's not really, doesn't look like it. Okay, Git branch. It is indeed, it's not too wrong, but I'm bad at counting. It is indeed correct. Okay, good thing, Git agrees. So part of these obviously come from the pack drafts file, right? And this is also what Git Oxide does. It actually has 2 iterators and it traverses them in lockstep. And because it knows that the output of both iterators is sorted, you can actually know that, you know, which iterator to advance. And then, you know, once one caught up with the other, and then one is more important than the other. So the loose refs, they override the packed refs because they are more recent always. And this is how this whole thing works. It's really like, and yeah, it's cool. Exactly. I thought, yeah, computer science, man. Because my naive thought was, of course, to implement it like, okay, now you have to iterate it, store it in a vector, sort that, and then you lose all the benefits of actual iteration and you have a lot of memory consumption and so on. But yeah, the properties of sorting, they actually remain if you iterate, and if you do that right, then, and Git, of course, knows that. So that's why I learned how to do that properly. And that's fun. It's great. Learn something there. All right, then. What about the next thing to check? Which one is it going to be?
Yeah, we could check the remotes. I mean, it's kind of the same thing, right? Just changing the prefix.
Mm-hmm. By the way, it's interesting, huh? Because I think we kind of have a subtle bug here. Because this one would also find other folders and things that are named like this. So the slash is actually important here, and this is what makes it so important to have this. So the common things, they won't result in errors like that or mistakes. Huh? So I think it makes sense. I would probably, you know, it's a question on how to expose this. I kind of feel more like individual functions here. But local and remote, I also like it. But that's the kind of API decisions that you then get to make. Do you like what Git2 did, or would you like to reinvent something else that kind of is the same but different, and you just think it's better or more intuitive, let's say? Don't know. So the number of remote branches, Okay. 9 and 8. Does that make sense? It does. Oh, so it says, let's actually review that. Okay. So I've got a bunch of origins here. And that looks correct. Nice. Tags. What about tags? Git tag. Alrighty. Now pack drafts are nice to have. 369. Okay. Then.
Same thing, right? Copy, paste, and replace.
Copy, paste, replace. There we go. It's like, you know, yeah, okay, I don't want to talk about the API now. Let's just focus on this, but I was feeling inspired. It's more like so many possibilities. It's also something, at some point I feel like the whole thing of being human is that you are like a predictive machine and you just know how to navigate the tree of possibilities. Whereas some possibilities are that you throw yourself out of the window, you know, it's a possibility, you can do that. It's just kind of not so useful to
reach. Not a very good one, yeah.
Yeah, not a very good decision to make. So the same with API, kind of narrow down all the possibilities to something that makes sense to most people, and that's then a good API, as people think and say. So yeah, 369 is what we want. 370. something happened. Okay, that's interesting. I don't know where that is coming from. I mean, clearly Git oxide picks up one more. And I don't know what that is because it will only look in... Yeah, it's also hard to kind of spot the difference without writing a file, but I guess we just... Because these are supposed to be sorted, right? Tags git. So let's quickly do something about this. So we should be able to map this tag. Do we get a tag name here? No method name found on result. Ah, yeah, right. Let's just unwrap this right here. Ah, now the IntelliSense is back to path. Okay, fine. To path works for me. So now we have something here to work with. Can I do toString?
So this is just a ref object essentially that you're working with there, right?
Yes, it's a ref. And now we convert that into a string. Welcome to Rust, where you build all these nice chains of conversions. And having IntelliJ or something like code intelligence is certainly a good thing to have, because who knows all these types by heart? I mean, there are people out there, but it ain't me. Okay, and now we can collect that thing. I want to write a file, by the way, in case it's not obvious, which it's not. I want to write a file similar to what I just did in one line of shell and like 15 characters. I want to do the same in Rust, and super easy and straightforward. So I collect it into a vector, then I can join it and join it along new lines. And this is how I get new line separated file thingy as a string that I can then dump into a file by just specifying the path. We call it tags.getoxide, and here is that. And that should write as a file with what's in there, and we should be able to diff it. There it is, nice. Diff tags. Wow, it looks very different. Like super different. Yeah. That's a bit unexpected too. It starts with like, okay, let's look at this. Oh, that's interesting. So that doesn't look too bad. Okay. Which one is which?
I think you had the
left?
Git open on the left one.
Okay, good. Otherwise, we will come to the conclusion they're all the same and are just more confused than before. Oh yeah, right. So that's actually, this is why. So we should only have the name and not the whole path. But internally, that's all they are, right? So that's the identity of the tag. And we just have to transform the name before this becomes comparable. Path file name. And that's now better. And we just unwrap this thing because we know there is a file name and we also don't care. And go again. Okay, so now that looks better. Let's try the diff again. Okay, so it's Git oxide v. So one side has the Git oxide v 0.82, and the other does not. This is why Git oxide has one more v 0.82. This one. Look at that. And that's the difference.
And why is that not being picked up by Git?
I have an hypothesis. Because Git is, Git says it's an idiot, but it's actually pretty smart. Git Oxide is more of an idiot right now. Oh, that's interesting. Oh. So I think Git must make a validity check of some sort. So this might be, maybe it's a, let's check, because look at this, huh? That's a bad object. So Git actually checks for valid objects and filters by that. And we also don't do that. And that's interesting because now Git tag is relatively high level. So should we expose that or not? Because I think Git Oxide should give you possibly broken refs and you have to figure it out yourself. I wouldn't pre-filter that, because that's not the level that Git Oxide operates on, or that this API operates on. So that's interesting to know as well. And that's interesting for the API to expose, like to communicate that to people. By the way, it might not actually exist, the object.
Yeah. No, I agree. I mean, otherwise you'd never actually really know that there's a broken object in there somewhere.
Yeah.
And this way you'd have to get past it somehow.
So that's an interesting thing. I think that could be something we actually put in as a number, like how many broken objects, how many broken refs are there. And for that, all we would have to do is check if the object that it points to exists. So for this one, I would even go with all. My brain is already filtering out the baby noises, but I realized it's actually quite present. So with all, I think here I would also go, I want to have as many results as possible. So I would go with result okay, and just take the ones that are working, which might be an interesting things to count as well, inaccessible ref. So what about filter result is count inaccessible refs.
Those would be the ones that are malformed somehow. There's some other error. Yeah.
Can't access, can't decode. Something didn't feel right. And it exposes this to you as well, because you want to be able to, write a tool that migrates refs or find refs that are broken and, generally not just fail because one ref is broken, but do as much as possible. But it's up to you, essentially. Inaccessible refs would be inaccessible refs. Okay. So now back to the broken refs. Broken refs with inaccessible objects. I think that's more like it. We can keep calling it broken refs for now. And now we have all the good ones. Now we want to dereference that somehow. We want to find the object. And actually it's more of a filter. I want to deref the object. Maybe a filter map. I can imagine that a lot of stuff can go wrong there, and I would just ignore errors. I don't know yet. Okay, it does not know what this is. Maybe we can give it a hint. This should be an owned reference that is an easy ref. So here, one of these. So see, I skipped git ref, which is a plumbing crate, and used the git repository easy namespaced one, which these will always return. And now we have things like name, which might be the path actually, and the ID. Oh, that's interesting. That's a good one. That's the ID that you point to, but it could point to an object that exists, but that object might be a tag object, and maybe that tag object then points to another object that doesn't exist. So we have multiple levels of indirections to traverse potentially, and it could be wrong at the first, it could be wrong at a later one. So the most thorough checking is certainly this one, it's a fully peeled ID, because that traverses the whole thing.
Yep.
And here I'd say if it can't traverse it, then yeah, then this is what we count. So it's more like is error here. That's it. And then this is not a filter map, then it's a filter. And then it's a count. Makes sense, or are there questions?
No, it makes sense, yeah. Should
Okay.
be correct.
Okay. Let's see. I would expect 1 to show up here. If it compiles, and it does not. Okay. Did I not compile anything here? Let's put this back down. Okay. It's all here, fortunately. Okay. Because question mark missing. And it's still unhappy. Because it should be filter map. You see, it got an option here because I mapped this into result OK, which is an option of the content, but filter map will break this down for me. Gosh, so I think we are getting there. Expected signature off. Oh yeah, the filter does not own. Fair enough. That's a bit of me being silly. And there. Oh yeah. This is I've run into this issue all the time, probably because I forgot question marks, and now it probably still doesn't work because oh yeah, right, now this isn't owned. Filter map. What about a filter map? Does that potentially work? Because that gets the owned item. So filter map we can do, and all we have to do is get the error, and then we have an option with an error inside, and then we count that. And it doesn't really matter that this is more, it's more like
true.
It's easy and it doesn't matter. The optimizer will optimize this. Oh, come on. Oh yeah, right. Now we have this. That, you know, this is why you probably don't want to put types here. It's just for IntelliJ. Yeah. Makes you more flexible. And just imagine, you know, how important type inference is. Like, I don't want to start ranting about programming languages who don't have that, but that's what you get if you have to specify the types everywhere. So, good news, it does work. And that's how the numbers are actually valid, you know, and that's pretty cool to see because we didn't even try that hard. 51 minutes in. And we know now that this probably wants to be improved in yeah, what probably is another session, because I don't really know. It's probably some more work to actually replace all this with some nicer functions or some nicer things, and also find an API, maybe even similar to this one, that is nice and maybe is better than what's already there. And I think since we started with this, we might as well explore how that would look like. I'm thinking in the direction of, not now of course, but more like branches. Maybe here you have an enum that says local or something, but maybe we could also go with this. And who knows, maybe even add a filter like that, so that you have a nice chain there going on, but you could have all the remotes that are more like this, or specific remote that is more like that. Something to explore. And I think then Git Oxide won't just be a copycat of Git 2, which already would make it pretty good, I think, but can be better. And I guess that's the whole point of doing these things, that you always try to get excellence instead of just being okay or good. Especially since you're the second one walking down that path that has already been laid out for you. So whenever I say this, it's not diminishing the value of Git 2 and the knowledge and just ingenuity that went in there. It's more like, yeah, we don't have to slay through the jungle anymore, and we should definitely do something with that, because we now can, and that's, I think, what I'm trying to say.
Instead, we're allowed to think of how can we make this even better.
Yes. We don't have to fight tigers.
Doing it the first time.
Yeah, if you don't have to defend yourself against tigers, you have a free mind to do all kinds of other things. You can draw pictures and paint and be artists, and our ancestors didn't have that luxury. They had to fend for their lives. And I think that's what makes this an opportunity here that I definitely don't want to miss. And that already looks pretty okay, but that's for another day. Maybe not even tomorrow, we will see. So that could be our session for today.
I think that's it. Cool. Then thank you very much.
And I thank you and our audience for watching, and see you next time. Bye-bye.
Bye-bye.